So this video will go over two things, graphing a linear inequality in two variables with y and x, and then being able to determine if an ordered pair is a solution to a linear inequality with both variables. So just as a review here, what we're coming from is we know how to graph an inequality in one variable. Like for instance, this graph here is if I just do this one here, this is the inequality of all the x's are in between 7.5 and 2.5. So this is an idea or an example of inequality with just one variable. There's only x's, so we just have one axis and we shade. We know when we do these types of inequalities, there's circles that we use. We call those border circles, meaning this is the end points of our interval, and we shade everywhere in between. So we have border circles. As we see in this example here, the borders can be closed circles or they can be open circles. And that's just depending on the original inequality. Lastly, because an inequality has so many solutions, we shade all the solutions. Over on the right side, we have an example of an inequality in two variables. Now, with two variables, what you'll notice is, for example, I have this is y, so like this graph over here, the inequality of y was less than x. So we can see a couple things here. First of all, since there's two variables, x and y, we are using the x and the y axis, whereas over here there was just an x, so we are just using the x-axis. But what we can see is that there's going to be a lot of similarities between inequalities in one variable and inequalities in two variables. So when we look at these examples up here, and this is just another example to the right here, that's just a different inequality. What we can see here is that there's still a border. Now, when there's two inequalities, those borders aren't circles, but instead those borders are lines. We can think of the border as separating, I'm going to write that down here. The border separates solutions from non-solutions, just like it did on the other side. That bubble, or in other words, this circle here, was separating these solutions from these things that were not. So what we can see here is that when we have two inequalities, those borders are lines rather than circles. It's a little bit hard to see on my picture here, but I'll be more specific when we do examples. Those lines can be open, which means they're dashed, maybe dotted, so like this is a dashed line, or they could be closed, filled in, so that'd be a solid line. And when we have inequalities in two variables, again, there's so many solutions that we can't list them, that we have to shade them all in. So there's a lot of similarities between variables or inequalities in one variable and inequalities in two variables. The last thing that's really important to note when it comes to the solutions, what we can see over here, and it still is true with an inequality in one variable as well, but just specifically looking over here, what we notice is that the solutions are all together, meaning they're on the same side of the line. Like I said, the same side of the border. Just like over here, all the solutions were together. They're all right in the middle here. All the solutions are right here. What we can see on this side, all the solutions that we shaded are below this line, whereas over here, all the solutions are above the line. So it's important to know that solutions all go together. So this will be our general method for graphing a linear inequality. So a great list of steps here for you to kind of pause and write down in your notes. What we're going to do, just as a general outline, first we're going to graph the borderline. Once we have that borderline, we're going to decide what side of it to shade. Again, there's a little more into that, but when we go through a specific example, we'll be more clear. So here I have two examples for us to do, and I did copy the list of steps that we would follow from the last slide just down here. So let's go ahead and address this first one. So the first step that we need to do is we need to graph the borderline. That's step number one. So when we graph the borderline, this is in slope-intercept form, so we can go ahead and place our y-intercept of 4, and our slope is 2, so up 2 and over 1. Now what you'll notice is I'm just placing dots for right now, because as our list of steps say, we need to make sure we know what type of border we are going to do. So in this case, we know an open circle, an open border comes from this or that. So what we have here is an open interval, so we are going to use a dashed line. Just like if it was in one variable, it would be an open circle, we're going to use an open line, which looks like a dashed line. Now, we need to figure out where to shade. So we're looking at this next step here. And as it tells us, and we noticed in the beginning, that all the solutions are on the same side of a line. So it doesn't matter what point we pick. I can choose a point here or choose a point here. I want to choose a point from one side of the line and test it. If that's a solution, that entire side will be a solution. If the point I choose is not a solution, the other side will be the answers. So let's just go ahead and pick a random point to test. I'm going to test this point right here. 1, 2, 3, 4, 5, 6, 1, 2. So this is the point 6, 4. So if it's a solution, it should satisfy the original inequality. So the y value would be less than 2 times the x value plus 4. So let's just go ahead and fill those values in for us. Our our y value is 4. The x value on that point was 6. So is 4 less than 12 plus 4? Or in other words, is 4 less than 16? So that's a yes. So this point is a solution, which means everything on this side is going to be a solution. So I'm going to shade the side where all the solutions would be. Now it's important to indicate, because we used an open line, points on the line are not solutions. Let's go ahead and look at this other example. So this other example, I'll use some different colors here. Now this is in standard form. I can use the intercepts to make a quick graph of that. So like my x-intercept would be the point 2, 0. My y-intercept would be the point 0, 4. So I go ahead and graph 2, 0 and 0, 4. Now if you wanted to, you could go ahead and convert that to slope-intercept form and use that to plot more points. There's nothing wrong with that. So I'm just showing plotting a few more points if I did convert. Now I don't need to convert, but again, if you wanted to, it's okay. Just using the intercepts is enough to create an accurate enough line. So on this one, we look at the original inequality symbol, and it's an open. So like on a number line, it'd be an open circle, which means here it's going to be an open line, which is a dotted line. So I've graphed the border. I'm going to choose a random point to test. So like this point right here, 0, 0, is clearly below the line. So I'm going to test this side. So if I plug it into the original, 2 times 0 plus 0, is that bigger than 4? So here I get 0 being bigger than 4, which is false. We see here that this number is not a solution. So nothing on this side is going to be a solution, which means the solutions are going to be on the other side of the line. If I had to graph the linear inequality here, I notice that this is going to be a horizontal line. Now they give me a coordinate plane here, and they want me to do it in 2 variables, so I know that this is a horizontal line. So I'm going to go ahead and draw that border line. So it's a horizontal line at y equals -3. Now, I'm just going to place a few dots that are on there because I need to connect it with the right type of symbol, or excuse me, the right type of line. Now, because this symbol, the greater than symbol, that would be like a closed circle. So if it's closed, that means we have a solid line to connect those dots. So now I need to decide where to shade. So to decide where to shade, I'm just going to choose a test point. So I'm going to again choose 0, 0. That's a nice point to test. If I plug the point 0, 0 in and test the original equation, all I need is the y value. So if I were to plug in the y value of 0, 0 is bigger than negative 3. That's true, so it's a solution. Now if 0, 0 is a solution, I would shade it in, but that means this entire side, all the points here are solutions. Like if I pick one, like this point, let's do this point right here. That's the point 10, 0. That point will satisfy the original inequality. So any point I choose on this side will be a solution. The last one we have to do as an example is x plus y is less than 2. So here I'm going to go ahead and use the intercepts to plot it. So the x-intercept, in other words, when y is 0, I'm just going to imagine this being a line for a second. If x plus y was exactly equal to 2, the x-intercept would be 2, 0. The y-intercept would be 0, 2. So I'm imagining the border line. Now when I connect these dots, because this is an open circle, or an open inequality, on a number line that'd be an open circle, and an open circle is the same thing as a dashed line. So when I connect them with a dashed line. Now I need to determine where am I going to shade, so I'm just going to pick a random point. I'm going to choose this point right here. So negative 1, 2, 3, 4. So the x value is negative 4, and the y value is negative 3. If I plug that back into the original, so the x value plus the y value should be less than 2. So if I plug that in, negative 4 plus negative 3, that's negative 7, and that is less than 2. So I know that this point is a solution, so I have found the side that has all the solutions on it. If this is a solution, every point on this side is a solution.